Hello everyone. Last week I introduced the kids and you guys to equivalent fractions, and this week we are focusing on actually comparing fractions. You're going to notice when I kind of walk you through this lesson that it's really important to know equivalent fractions because that helps us even when we compare fractions. So there's three strategies I'm going to show. The first one is the easiest one, and that is when you have two fractions that have the same denominator. Because ultimately, we would like the fraction to have the same whole, because it's easier to compare when they do. So for example, 5, 6, this is a picture showing that you are literally 1 away from the entire whole of 6. And then 1, 6, notice that we are 5 away. So if I visually look at this, it has the same whole. 5, 6 is going to be obviously larger than 1, 6. Another example, if it has the same whole common denominator, 10 twelfths is obviously greater than 5 twelfths. Because here I'm only 2 away from my whole, whereas here I am 7 away from my whole. Kids do a really good job whenever they have fractions with the same denominators, whenever they compare. Because again, you have the same whole. Next strategy is going to be known as benchmarking. So we're really going to get into this week. And this might be something new that you've not seen before. But benchmark fractions, kids are really good about knowing how much a fourth is, a half, and 3/4. So we use these benchmark fractions to determine where to place fractions on the number line. So if you notice here, we've drawn out the number line. We've put our benchmark fractions, a fourth, a half, and 3/4. And I'm comparing 3/6 to 7/8. I know that 3/6 is a half. So if I were to place that on my benchmark number line, it would go right on the half because it's the same exact fraction. If I look at 7/8, I think, okay, well 7/8, you're only 1 away from the whole. So I would place it behind the 3/4. How do I know that 7/8 comes behind the 3/4 and not in front of it? Because 8 is a bigger whole than 4. Both of these fractions are 1 away from its whole. Because I'm out of 8s here and I'm out of 4 here, 7/8 is larger because the whole is larger. So when I look at it, and I've plotted 3, 6, and 7/8 using my benchmark fractions, I can tell that 7/8 is larger than 3, 6. Another example of this is, again, I'm plotting a fourth, a half, and 3/4. I'm looking at 7 twelfths and 1/3. If I look at 7 twelfths, I know that a half would be 6 twelfths because half of my denominator is 6. Well, this is 7 twelfths. So this lets me know this has to be a little bit more than the half. So that's where I'm going to plot it. If I look at my third, I know that there's a fourth and then a half. That 1/3 comes between my fourth and my half. So when I look at it, I know that 7 twelfths is bigger than 1/3. So the kids are going to be doing a lot of benchmarking where they're having to use a fourth, a half, and 3/4 to help them determine where to plot the actual fractions being compared and then looking at the number line to compare them. The third and final strategy that students are going to learn is going to be finding that least common denominator, or the LCD. Looking at fractions 7 twelfths and 1/3, the whole goal of comparing fractions is, like I said, it's trying to find that common denominator, that same whole. And in this case, I don't have the same whole. But I can try to make one of these fractions equivalent so that I do have the same whole. I always first see the larger denominator and see if that can be the whole that I want to kind of get to for my other fraction. And in this case, yes, it is. I know that I can make 1/3 something out of twelfths. So I look and I am going to use that equivalent fraction. 1/3, if I times it by 4, gives me 4 twelfths. Therefore, 7 twelfths is greater than 1/3. Another way of saying a third is really 4 twelfths. So if you're comparing the same whole now, I can. 7 twelfths compared to 4 twelfths. Therefore, again, 7 twelfths is greater than a third. Then you have examples where the larger denominator doesn't work. In this case here, 8 times something isn't going to give me 12. So I have to find a common denominator, a common whole that these two have. And how do I do that? I use multiples. So I find the multiples of 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. I do the same for 12. 12 times 1 is 12. 12 times 2 is 24. At this point, I can stop because I found a least common denominator that they have. And I set it equal. I'm finding equivalent fractions. So 12 times 2 gives me 24. 9 times 2 gives me 18. So 9/12, this original fraction, really is 18/24. If I want to do the same thing for 5/8, I'm going to say 8 times 3 to give me 24, 5 times 3 to give me 15. So 5/8 is really 15/24. Now that I had them having the same common denominator, I can compare them. So 9/12 is greater than 5/8 because really I'm comparing 18/24 to 15/24. Another example of least common denominator, I go back to 9/16 and 3/4. I first check to see if that larger denominator is going to be my common denominator. And again, in this case, it is because I know I can multiply 3/4 times something to get me that 16. And in this case here, it would be the 4. 4 times 4 is 16. 3 times 4 is 12. So 9/16 is actually less than 3/4 because 3/4 is really 12/16. And I just proved that over here when I use an equivalent fraction to find the same exact whole. Here's another example of where the 9, the larger denominator, I can never say 7 times something to give me 9. But 9 and 7 have something in common with each other. I just have to find it. So again, going back to using my multiples, I find my multiples of 9, I find my multiples of 7, and 63 happens to be that common denominator. So I set it up to 63. Going back to 7/9, here it is. 7 times 7 is 49. 9 times 7 is at 63. There's my 6/7. 6 times 9 is 54. 7 times 9 is 63. Now I can compare them easily because it's out of the same whole of 63. Therefore, 7/9 is less than 6/7 because 7/9 is really 49 out of 63 and 6/7 is 54 out of 63. So again, 3 ways that you can compare fractions. Anytime you have common denominators, the same whole, the same denominators, kids are easily going to be able to compare because it's already the same whole number, which is really nice. Kids also have an opportunity to use benchmarking, okay? This isn't as accurate as an LCD, but for some kids, they're very good at being able to plot it on a number line, and they're able to look at it and know where to place it, and by placing it, it already orders or compares the numbers. So using 1/4, 1/2, and 3/4. Lastly, another strategy they can always use is finding that least common denominator. The whole point is to try to get the same whole. And if you can get the same whole, you can compare it. Always first see when comparing 2 fractions if the larger denominator is the number you can use to get the same whole. If it is, great, use it. If it's not, you're going to have to find the multiples of the 2 denominators to find that common whole. I hope this has been very helpful, and if you have any questions, please feel free to email me. Thanks so much.